Hello, welcome back, Math 10. Today we are going to look at integral exponents, also known as negative exponents. So what happens when the exponent is negative? So to start off here, I have a little pattern for us to follow. 10 to the 3 is the same as 1,000, because as we learned last lesson, that's 10 times 10 times 10 times 10. 10 squared is the same as 10 times 10, which is 100. 10 to the power of 1 is the same as 10. Now, 10 to the power of 0, we learned last lesson, is always going to be 1. So if I look at this, we're always dividing by 10. As we go down, we divide from there to there. We have to divide by 10. So to go down, we divide by 10. To go down more, we divide by 10. Okay? So every time we decrease 1, we divide by 10. Now to go to negative 1, if I look, we minus 1, always. We're going down by 1. So to go down by negative 1, we must divide by 10. Well, what is 10 divided, or 1 divided by 10? It's going to be 1 over 10, or 0.1. Let's take a look at the next one. Then to go to the next step, we must follow my pattern. Divide by 10. This is going to be 1 over 100. Okay? So this one here is going to be 1 over 1,000. Well, isn't that interesting? Look at 10 to the negative 3 and 10 to the 3. Look at their answers. How are they related? Look at 10 to the negative 2 and 10 to the 2. 10 to the power 2. Look how they're related. Okay, so now let's take a look at the 3's. I put a 1 there, right? 3 to the power 0 is always 1. If I look at this divided by this is 3. So I divide this by 3 to get 9. To go from 9 to 3, I have to divide that by 3. Once again, divide by 3. So then I'm always dividing by 3 as I go down, because my base is 3. We divide by the base. Okay? As my exponent decreases by 1, we divide by the base. Okay? So now, to go this to the next step, I must divide by 3 again. So that's 1 over 3. So then to go from this step here to the next one, we divide by 3 again. So that's going to give me 1 over 3 squared, which is 9. And then we do it one more time, divide by 3 again. That's 1 over 3 times 9 is 1 over 27. Now look how this is related. How is that related to this? How is this one here related to that? Isn't that interesting? Now whenever we do these, we want to leave them as a fraction. Okay? And it's very interesting how these line up. Look how this relates to that. This relates to that. Very interesting. Okay? Now let's take a look at another way of looking. Okay? We have 5 exponent 4 divided by the power 5 exponent 7. Let's expand each, write it out. What does it mean? This means 5 to the 5 multiplied by 5 multiplied by 5 multiplied by 5, right? That's 5 to the exponent 4 over 5 exponent 7. So we have to divide that by 5, 1, 2, 3, 4, 5, 6, 7. Now, if I look at this, we could just start canceling off. 5 divided by 5 is 1. 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 So I'm left with 1 over 5 to the 3. That's kind of interesting. Now, let's take a look at the quotient law that we learned last time. Well, this is, if we're dividing, that means we have to subtract. That's 5 to the power of 4, subtract 7, which gives me 5 to the negative 3. So basically, this and this must be the same thing. So can you make a law with integral exponents? By combining these two, can you make a law with integral exponents? Can you put it in algebra? So then if I said a to the negative b, what does that equal to? What's another way of writing that? Can you find that out? Okay, I want you to pause, write that down, and then I'll check for it tomorrow in class. So let's take a look at this next part here. It says, convert the following to positive exponents. We want a positive exponent, so we're going to use what's called the integral law. So 2 to the negative 1 is the same thing as 1 over 2 to the power of 1. 3 to the negative 2 is the same thing as 1 over 3 to the 2. Okay? Okay. Now if I continue this, it's the same thing as 1 over 9. Okay? Either or of these answers are good. Let's try the next one. 4 to the negative 3. Well, that is 1 over 4 to the 3. Because which is the same as 1 over 64. Okay? These here are good enough answers. So basically, whenever we have a negative exponent, we just have to flip it. Okay? We just take the reciprocal. Now it wants us to show that this is equivalent to that. Well, how do I do that? Well, we have 1 over 4 to the negative 3 is equal to 4 to the 3. Well, let's show that's true. So I'm going to flip this. This is 1 divided by 1 over 4 to the 3, because I just flipped this part here is equal to 1 over 4 to the positive 3. If I made that exponent positive. Now, this is equal to 4 to the power of 3. Now I look at this, I have a division. This is saying 1 divided by 1 over 4 to the 3. So I'm going to write that out. 1 divided by 1 over 4 to the power of 3. Now if we remember way back when we did division of fractions, leavey, samey, changey, wangey, uppy, downy, leave this the same, changey, wangey the sign, uppy goes downy. So I'm going to be left with 1 multiplied by changey, wangey, right? And then uppy, downy. We have 4 to the power of 3 divided by 1, which is equal to 4 to the power of 3. And that is true. 1 times 4 to the power of 3 over 1 is just 4 to the power of 3 is equal to 4 to the power of 3. And if we want, we could check in our calculator. How do we do that? I'm just going to go 4 to the power of 3. There's 3. Enter. And then I'm going to go 1, bracket 1 divided by 4, all to the power of negative 3. 3. 1 divided by 4 to the power of negative 3. And enter, and I get 64. So on the calculator, they show the exact same thing. There we go. They're both equal to 64. So now let's simplify and express each as a positive exponent. Okay, so we want positives. So here I have 4 to the 5 all over 4 to the negative 3. Well, that's the same thing as plus negative 3. I could look at it that way, which is the same as 4 squared. Or I could look at it this way. Divided by 4 to the power of 3. Right? Multiplied by 1 over 4 to the 3. It's the same thing as dividing, which is the same thing as 4 to the 5 minus 3, which is 4 squared. Okay? Let's take a look at the next one. We have negative 5. I'm going to try this one in an even different way. So I'm going to 3 multiplied by 3. Okay? Or 3 squared. Okay? Now this is saying multiplied by 1 over 3 to the 5. Okay? So if I do that, that's 3 squared all over 3 to the 5. This is division. Alright? So what does that make us? That's going to give me 3 to the negative 3. We subtract those. Okay? Or I could have just gone this plus negative 5, which gives me negative 3. Let's take a look at my next one. 1 over 2 to the negative 5. So that's 1 all over 2 to the negative 5. Well, I want to flip this. That's the same thing as saying 2 to the negative 5, or 2 to the 5 all over 1, which is 2 to the power of 5. Okay? Let's take a look at my next one here. Well, this is negative. This wants to go on top. This is negative. It wants to go on the bottom. It's on top. It wants to go on the bottom. So we're going to end up getting 6 to the 5 all over 6 to the 7. I subtract these. I'm going to end up getting 1 over 6 squared. Okay? Let's take a look at this next one here. 2 to 3 all to 3. That's 2 to the negative 6. Well, I have to take the reciprocal because it's negative. That is 1 over 2 to the power of 6. There we go. Done! Alright, so now we want to simplify this one and write it as a positive exponent. Exact same thing, except now we have algebra. So I go like that. This is adding. So it's like a minus 3 plus minus 4 plus negative 3, which gives me a to the negative 7, right? Well, that's a negative, so I'm going to flip it. That's 1 over a to the 7th. There we go. Positive exponent, and we are done. So that is everything here. I'll give you one more example that's a little bit more complicated. Let's try this one here. If I have a to the 3 divided by a to the negative 5, well, what's that going to be? This is the same as a to the 3 multiplied by a to the 5, which gives me a to the 8. Okay? We just flipped this one. This one's negative, not that one. We only flipped the negative exponent. So that's one more example for you to think about and look at. Okay? Well, hopefully you understood. Good luck as I see you tomorrow and we work on these together as a class. See you tomorrow.